This video will serve as a summary for reaction mechanisms of families of organic compounds which are not purely hydrocarbons. So back to the RX compounds, we know that in the way I teached, or in the way that I taught, these RX compounds, these can include alcohols, amines, and alkyl halides. Generally, these three can all react by two ways. It could use a nucleophile, since the R here is partially positive because any of the functional groups of these three are partially negative or are electronegative. So nucleophiles are negative. We have a partially positive R here. Nucleophile is usually negative. Sometimes it's neutral. But the point is the nucleophile will replace this X, which acts as a leaving group. This one is the substrate. The nucleophile attacks the substrate. So what we will get is the R will bond to the nucleophile, and the leaving group will leave. The X here leaves. And since we know that a nucleophile attacks, and this is a substitution reaction, this is SN, and we know that we could further subdivide this into either SN1 or SN2 based on the factors that we have discussed previously. Now we could now use another reagent, which is a base, and if we have a base there, we will be able to produce an alkene, because once the X goes away and the beta hydrogen has been swiped by the base, we would have a positive and a negative carbon, and in order to remove those charges, we produce a double bond, forming an alkene. We have discussed that bit by bit in the previous part for elimination. And yes, again, the mechanism is elimination. Now here we have alcohols, and actually this is for redox reactions. If we oxidize a primary alcohol, we would produce this RCHO, or an aldehyde. Alright, an aldehyde. And we know that an aldehyde, unlike its counterpart ketone, is oxidizable. And if you oxidize an aldehyde, you will produce RCOOH, and that is a carboxylic acid. Now, if you have a secondary alcohol instead and you oxidize it, you will come up with, this time, a ketone. And since we already mentioned that ketones do not have any more oxidizable hydrogens, ketones cannot be further oxidized. But then again, we have arrows here indicating that you could reduce all of this back to alcohols. Alright, so that's for redox reactions among alcohols, aldehydes, ketones, and carboxylic acids. Now, here we have the carbonyl compounds. If this one is H, we have an aldehyde. If this one is C, we have a ketone. So I just put here carbonyl compounds, and we know that the target site here is this partially positive carbon. And if we have a partially positive carbon, then it would be attacked by something either neutral or negative. That's a nucleophile again. And since we do know that this bond C to H or C to C is nonpolar in both cases, the only way that you could sacrifice a bond for carbon in order to accommodate this nucleophile is removing this pi bond. So as a result, you will now form a single bond now to O in order to accommodate the nucleophile, which would attach here. And so this is A and this is B. You combine them to form AB. This is addition, right? And so the mechanism of action is nucleophilic addition. Now, finally, when you have here RC double bond O, a leaving group, the leaving group can be OH, it could be X, it could be an acyl group, It could be an alkoxy group or it could be an amino group. Remember, those are the substituents respectively for acid halides, anhydrides, carboxylic acids, esters, and amides. So here I'm talking about carboxylic acids and their derivatives. So other than the fact that they could undergo redox reactions, generally, again, here we have also a partially positive carbon, but this time, unlike the carbonyl compounds which have a stable C2H or C2C bond, this one is polar. So instead of sacrificing this pi bond here, you don't have to sacrifice that. All you need to do, anyway, these are leaving groups, and so these leaving groups will go away, and then the nucleophile, remember, nucleophile will be the one involved here because anyway, we have a partially positive here, we have negative, they match together. The nucleophile, instead of breaking this pi bond in this carboxylic acids or derivatives, they will just, they will just take away the leaving group, or they will just let the leaving group leave, and then when the leaving group does leave, the nucleophile will then take the place of what used to be the spot of the leaving group, and the leaving group will be a byproduct. Since there is a replacement of something, we say that this is a substitution, specifically nucleophilic substitution. But specifically, since we are dealing with groups that we are dealing with compounds that have this RC double bond O or acyl groups, we completely name this as nucleophilic acyl substitution. Again, alcohols, amines, and alkyl halides, the RX compounds in my way of teaching, either nucleophilic substitution or elimination, SN1 or SN2, E1 or E2. Alcohols can be oxidized to either aldehydes or ketones, and aldehydes can be oxidized to carboxylic acids, and vice versa. Carboxylic acid reduced to aldehydes, aldehydes and ketones reduced back to alcohols. Aldehydes and ketones, which are carbonyl compounds, acting upon nucleophiles in order to produce either, as we review them, either a hydrate, a hemiacetal or hemiketal, an acetal or ketal, or an imine, or even an alcohol by Grignard reaction. So all of that undergoes the mechanism of nucleophilic addition. Sometimes nucleophilic addition with elimination in cases of imine formation, Grignard reaction, and acetal formation. So those are three. Okay, again, imine formation, acetal or ketal formation, and Grignard reaction. There's an additional elimination specifically of water. And finally, for carboxylic acids and derivatives, again, the leaving group leaves, nucleophile takes place in order to produce a product, and the leaving group as byproduct. So that's a replacement reaction, that is nucleophilic acyl substitution. And we know that nucleophilic acyl substitutions can come in the form of hydrolysis, formation, interconversion of derivatives to one another, such as esterification, ammonolysis, aminolysis, transesterification, and don't forget that, again, carboxylic acids and derivatives can also undergo redox reactions, such as nitriles reduced to amides, and amides reduced back to amines, and vice versa. So that's it for the rest of the families which are not hydrocarbons.